The Internet is on the cusp of a profound transformation. We have witnessed the static, read-only pages of Web 1.0, the user-generated content and social platforms of Web 2.0, and the decentralized, data-centric promise of Web 3.0. Now, a new paradigm is emerging that promises to be more revolutionary than all that came before. Web 4.0, also known as the intelligent web, the autonomous web, or the symbiotic web. This is not merely an incremental upgrade. It represents a fundamental shift in how we interact with technology and how technology interacts with us. It is a move from an internet that we actively use to an internet that actively participates in our lives, anticipating our needs and acting on our behalf. Web 4.0 envisions a world where the boundaries between the physical and digital realms dissolve, where advanced artificial intelligence becomes a seamless part of our daily existence, and where autonomous agents navigate the complexities of the digital world for us. Understanding Web 4.0 requires a clear appreciation of the evolutionary journey of the Internet. Each generation has been defined by a distinct shift in control and interaction. Web 1.0, the era from roughly 1991 to 2004, was the age of static, read-only documents served from centralized servers. Users were passive consumers of information, with technologies like HTML and HTTP providing the foundational infrastructure. The early Internet was essentially a digital library where information was published for consumption. Web 2.0, emerging around 2004, transformed the Internet into a platform for interaction and contribution. With the rise of social media, blogs, and collaborative platforms, users became creators and contributors. Technologies like REST APIs, AJAX, and social graphs facilitated user-generated content and platform-mediated interaction, marking the era of read-write web. This generation democratized content creation and gave rise to the massive social networks that dominate our digital lives today. Web 3.0, beginning around 2014, took a different direction, focusing on decentralization, semantic web standards, and data ownership. It proposed an internet where users own their data and digital identities through blockchain technology and smart contracts. Web 3.0 was the web of data and the web of trust, where machine-readable data and decentralized protocols aimed to break the monopolies of Web 2.0 platforms. But where Web 3.0 answered the critical question of who owns data, Web 4.0 asks the next logical question: who acts on it? Web 4.0 builds upon the decentralized foundation of Web 3.0 and activates it, adding a layer of autonomous AI that can not only own and control data, but also perform complex tasks on behalf of users. It represents a progression from ownership to delegation, from being a user to being a delegator and co-pilot. The European Commission, a key proponent of this vision, formally defines Web 4.0 as the expected fourth generation of the World Wide Web that leverages advanced artificial and ambient intelligence, the Internet of Things, IoT, trusted blockchain transactions, and extended reality capabilities. This definition encapsulates the technological pillars that support the Web 4.0 ecosystem. The core of the European strategy, articulated in its 2023 communication, aims to steer this transition to reflect EU values and principles, ensuring an open, secure, and inclusive digital environment for citizens and businesses. The Commission recognizes Web 4.0 as a major technological transition that will build a seamlessly connected, intelligent, and immersive world, and it is crucial to get the governance and standards right from the outset. At the heart of Web 4.0 lies the concept of the autonomous AI agent. Unlike traditional AI that responds to a prompt and stops, these agents are stateful and proactive. They can plan multi-step tasks, call external tools, and initiate new requests without waiting for human instructions at every step. This represents a leap from predictive AI to agentic AI, systems that can reason, plan, and act independently. Demis Hassabis, CEO of Google DeepMind, provided a glimpse of this future with Project Astra, a prototype that can listen to conversations, observe environments via camera, and suggest actions like rescheduling a flight or finding lost keys. This is a world where our digital assistants become truly proactive, anticipating our needs and handling complex tasks before we even ask. The shift has profound implications for how we interact with the web and with brands. As noted by experts, our next customer might not even type a query into a search engine. Their AI agent will simply choose what it believes is best, making trust, reliability, and structured data paramount for businesses. This human-machine symbiosis is the second conceptual pillar of Web 4.0. It goes beyond simple automation to a bidirectional learning relationship where human preferences refine agent behavior, and the outputs of agents reshape how humans formulate new goals. In practical terms, this means that the digital systems we interact with will learn our specific vocabulary, our preferences, and our habits over time, creating a deeply personalized experience. This symbiotic relationship can be seen in advanced applications where LLM-driven agents in logistics and healthcare not only automate tasks, but also surface edge cases that cause operations teams to reevaluate and refine their own decision-making criteria. To make this vision a reality, Web 4.0 relies on a convergence of several key technologies, each playing a critical role in creating an intelligent, decentralized, and immersive web. The first of these is the integration of advanced AI and deep learning. It underpins almost every other aspect of Web 4.0, enabling the transition from the rigid, query-based interactions of previous web generations to a fluid, contextual, and natural language-based interface. The interaction model shifts from navigating a user interface to stating an intent, with natural language processing allowing systems to interpret complex and ambiguous queries. This is the foundation of the intelligent aspect of Web 4.0, where the web understands context and meaning rather than just keywords. The second foundational technology is the Internet of Things, IoT. For the physical and digital worlds to fully merge, the web must be able to perceive and interact with the physical environment. IoT achieves this by connecting billions of smart devices, sensors, wearables, appliances, and industrial machinery that generate a constant stream of real-time data. In a Web 4.0 context, this goes beyond simple telemetry to bidirectional machine-to-machine, M2M, coordination. Each connected device becomes an agent participant, capable of signing transactions, consuming micropayment rails, and acting on behalf of a user without human intervention. This M2M communication, combined with cloud computing and edge inference, creates a perception layer for the web, enabling new applications in smart cities, industrial automation, and healthcare. The third pillar is the use of decentralized protocols and blockchain for identity and trust. For autonomous AI agents to act on a user's behalf across organizational boundaries without creating new central trust bottlenecks, a robust and secure system of decentralized identity is essential. Web 3.0 introduced the concept of ownership. Web 4.0 requires a live trust layer. Decentralized identifiers, DIDs, now a formal standard from the W3C, replace username, password authentication with cryptographic proofs. Zero-knowledge proofs allow a user to confirm a claim, for instance, that they are over 18, without revealing the underlying data. This technology is critical for agents to negotiate, transact, and interact securely in a decentralized environment. However, the governance risk is significant. When there's no central authority to reset a credential, key recovery falls entirely on the user. The fourth technology is spatial computing and extended reality, XR, the bridge that merges the digital and physical in an immersive manner. Web 4.0 is not confined to a screen. It extends into our physical space through augmented reality overlays, digital twins, and immersive virtual environments. VirtualWorlds, defined by the European Commission as persistent, immersive environments in 3D, are a key component of this. These are not just for gaming or entertainment. They are used for designing, making simulations, collaborating, learning, and even performing transactions. A digital twin of a manufacturing line is a live, intelligent model that autonomous agents can query and act upon to trigger physical changes. Boeing uses digital twins to reduce aircraft assembly errors, and healthcare providers are beginning to use them for surgical planning. This integration of spatial computing and AR/VR creates what is known as the Web of Things, or the symbiotic web, where interaction is not with a screen, but with an immersive field of view. The impact of Web 4.0 will be felt across virtually every sector. The European Commission has outlined how virtual worlds and Web 4.0 technologies will transform various industries. In manufacturing, industrial virtual worlds could reduce car delivery times by 60% and cut carbon footprints by 50% by 2025. In healthcare, virtual worlds enable surgical simulations that can reduce the risk of complications and improve diagnostic accuracy. The education sector stands to benefit immensely from virtual classrooms, where abstract subjects can be visualized and scientific experiments simulated, accelerating learning. Even the cultural and creative sectors will be transformed, offering new ways to promote and consume cultural content, creating immersive experiences of museums and concerts from the comfort of home. The implications for business are equally transformative. The rise of AI agents as primary consumers of web content is already reshaping how businesses approach their online presence. As noted by Daniel Instandig, the next customer might never Google a service or click an ad. Their AI agent will just choose what it thinks is best. This creates a new imperative for businesses to ensure their online presence is machine-readable, trustworthy, and optimized for agent interaction. It moves the challenge from search engine optimization, SEO, to agent experience optimization, EXO. This shift is driving a new focus on context and relevance over content volume, as creators today are effectively setting the standards for how AI and humans will interact in the future. As stated by Brian Solis, content alone is no longer king, context is. However, the path to this intelligent, symbiotic web is not without its challenges. The governance of autonomous agents presents a major risk, as recursive self-improvement could cause an agent to drift from its original objective, making it difficult to audit. The AI tax, where users uncritically accept incorrect information from AI systems, is already a burden, with 80% of users accepting an AI's incorrect answer without question, eroding trust. Privacy concerns are paramount, as the hyper-personalized experiences of Web 4.0 require vast amounts of personal data. Decentralized identity and federated learning are partial solutions, but they require careful implementation to prevent new forms of inequity and surveillance. The European Commission strategy is explicitly designed to address some of these challenges, aiming to ensure Web 4.0 reflects fundamental rights and EU values. Web 4.0 is more than just a technological evolution. It is a societal one. It represents a shift from a web of information to a web of action. It is an internet that understands the world, anticipates our needs, and empowers autonomous agents to act on our behalf. From the intelligence of AI to the trust of blockchain, from the connectivity of IoT to the immersion of spatial computing, Web 4.0 is building the infrastructure for a truly symbiotic relationship between humans and machines. While it is still in its early stages, its development is being actively shaped by governments, businesses, and technologists around the world. The challenge and the opportunity of the next decade will be to build an intelligent web that expands human creativity and potential, rather than one that diminishes it. The development of standards, the governance of AI, and the protection of user rights will determine whether Web 4.0 becomes a tool for liberation or an instrument of control.